Welcome back to the Part 6 tutorial FastAPI in Python. In this video, we'll create post operations with request body and use Pydantic models for data validation. By the end, the clients of your API will be able to send and add users' data through your API. This will be a long lesson. Let's get started. Hi everyone, I'm Leanne. Welcome to Just Into Data, where data science and data engineer materials are shared and made simpler for you. We'll start by reviewing some basic concepts. What is request body and what is response body? The request body is data sent by the client to the API. For example, you can think of the web browser as the client. It can send requests with request body to our API, while the response body is the data sent by the API to the client. We've seen this already in the previous videos. When we send GET request to our API, the API returns the user data as response body. So the request and response body are both data transmitted between client and API. The request body is optional, which means the client doesn't have to send any data to the API, while the API would almost always have to send a response body back to the client. In this video, we'll focus on the request body since we want to send and add data to the API. Let's also recap on the HTTP operations. In the previous videos, we've been using the GET method to retrieve data. As you may recall, when we executed the request, we weren't sending any data to the API. That's because we are only retrieving data, and the GET operation is a read-only operation. But there are other main operations where we can send data or request bodies to the API. We'll be covering the other four methods below: post, put, patch, and delete. Among them, the more common operation is post, which is used to send and create data. So in this video, we'll first learn about the post operation. Alright, now let's go to PyCharm to start our coding. We'll add a new operation below the previous GET operations. The syntax is the same. We'll first set up the decorator at app dot. As mentioned, we're going to use the post operation. Within the parentheses, we'll put the path as /users again. So whenever there's a post request sent to the path of users, this decorator will be called. Then as before, we'll need to define the function below. Def, function name, call it createUser, since the post operation is used to create data, followed by parentheses, colon. Since we are creating data, the client definitely needs to send some data or request body to this function. Let's put an argument called user. This user should contain the data sent to the API, which means this user should be the request body going to the API. So how should we define this user object? If you scroll up, look at our database, UserDB, there are specific fields included for each user. We have username, date joined, location, and age. So when we are creating users and add them to this database, we should make sure the new user had those fields as well. How can we make sure we're sending data with this particular fields? We need some data validation tools to guarantee that. Going back to the post operation, we can set up a model for this object user. Say call the model user with capital U. And we can set up this model with the help of Pydantic. We've talked so much about Pydantic. What is Pydantic? Pydantic is a data validation library based on Python type hints. It can validate data by enforcing type hints. And FastAPI is built based on Pydantic for its data parts. So in summary, FastAPI took advantage of Python type hints through Pydantic. It gets all the nice data validation features. We've already used Pydantic in the previous videos, where we define the path or query parameter with data types. In those examples, we've used the standard Python data types like string and integer. We can also custom define our own data types through Pydantic models. Pydantic model is the main method of defining objects in Pydantic. They're basically classes inherit from Pydantic's base model. So in our example post operation, we can create a class based on Pydantic base model, and then use such class as a model to define the request body or the data that we'll be sending to the API. I hope you have some basic knowledge of Python classes and instances. Here is a quick recap. Python classes are like the constructors of objects. They are more like the model or blueprints for creating objects. So, creating a new class creates a new type of object. Once we have a class defined, so we know how the object should look like, we can create objects by creating instances. So when we are creating a new instance based on a class, we're creating an actual object. So again, creating a class is describing how a new type of object will be, while creating a new instance is when we actually create an object. Here is a basic syntax of classes and instances in Python. To define a new class, we use a keyword class, followed by the class name, and statements to describe the class. Assume now we have a new class called class name. It has all the details of how this new type of object should look like. Then we can actually create an object by creating an instance based on such class, which is also called instantiation. Now, this instance name is an actual object. It follows the statements within the class we've defined. There are a lot more to Python classes and instances. You can explore more as needed. Alright, now it's time to go back to our code. So we need to build a Pydantic model for our data of users. As we've learned, the Pydantic models are classes. We've already called such class user with capital U. So this class user, the Pydantic model, will limit how the object user looks like. Now we need to define the class user. Let's add it after the database. So here, we've quickly reviewed the syntax of defining classes. So starting with keyword class, followed by the class name, user with capital U, then followed by parentheses. Within the parentheses, we need to put base model. Since to use this class as a Pydantic model, it needs to inherit from Pydantic's base model. So we also need to import this base model. Let's scroll up and add from Pydantic import base model. So again, we are creating a new class called user, inherits from Pydantic's base model. So we'll be using to use this class user as a Pydantic model. Then don't forget to add colon and press enter. Here we can put statements to describe this new class. As you can see, defining a new class has somewhat similar syntax as defining a function in Python. We'll define the fields for this class user. Based on our database, there are username, date joined, location, and age. And we'll keep things simple and only declare their basic types. So we'll just declare username as string, so our date joined and location, the age should be integer. And that's it for the class user. Now we have a new class called user with capital U, inherits from Pydantic's base model with 4 fields declared. So now we can use it as a Pydantic model in FastAPI. We'll scroll back down to the post operation we've set up earlier. We've already put the class user here as the model for user. This is great. So whenever we send a post request with this argument of user, this user needs to look like its model user with those 4 fields. And since we've declared type for those fields within user, we'll get all the benefits of type hints we've talked about before. First, FastAPI will automatically convert the request to the required type. And when the data is invalid, FastAPI will generate automatic errors. Also, as we type more code, the editors like PyCharm provide support such as type checks and auto-completion. Let's test some out. We'll go back to the post operation. Within the function, we'll say username equals the input user dot there's a pop-up. That's the auto-completion we've talked about. PyCharm now gives us hints and help us to complete the code. You can see the options of the 4 fields for this model. We'll select username and press enter. So now the variable username stores a value of the field username from user. What if I make a typo, so I add an S to the end? This is the error checking we've talked about. PyCharm highlighted it and give a message here, and resolved attribute reference usernames for class user. Since there's no such attribute of username with S, PyCharm is warning us. So let's remove the S. It's all good again. Then we can add data to our database. The database is represented by the variable userdb. So we can add to userdb with square brackets, username equals user.dict for dictionary. This dict method converts the data of user into a dictionary. This is necessary because user, as a model of class user, it needs to be converted to dictionary. So we're adding to userdb a key of username and value as a dictionary from user. This matches with the existing database structure. If we scroll back up, you can see that within userdb, the keys are the usernames, and the values of the keys are the data of such users as dictionaries. Alright, let's go back to the function. To close this function, we'll say return a dictionary with key as message, value as an S string, successfully created user, colon, curly brackets a placeholder for strings, and put the variable username inside. So the function just returns a message telling us we've created a user with such username, and that's all. One small thing before we run the code. Let's also go above to the get operation, change the query parameter limit's default value to 20. This is just convenient for us when we want to verify the results of the post operations. Alright, let's save this so that the changes of the code are reloaded, and go to the browser to look at the documentation. There is our post operation to the path of users. Let's expand and try it out. As you can see, there is this new tab called Request Body. Again, the request body is the data the client sends to the API. It is required, and FastAPI will read this request body as JSON. We've also declared the 4 fields of the model, so you can see them here. There are also some values corresponding to their data types. We've set these 3 fields as strings, so they are default to string. Age as integer, so it's 0. We can certainly change them. Let's say we'll add a user named Jason. Date joined as 2000 January 1st. Location of Earth, and age of 100. Let's execute this. You can see that the request URL is to the path of users, and we've got a 200 success response code. The response body is message successfully created user Jason. This is a dictionary we've asked the function to return. Let's try another one. We can scroll back up, and let's keep the other data the same, but change age to a string of 5, so F-I-V-E. So it is not integer anymore. Let's try execute it. So this didn't work. We've got a code that's not 200, so the operation was terminated since the data wasn't validated based on a Pydantic model. Age can only be integer, but not string, so Pydantic did validate our request body data. Alright, so we've successfully added one user named Jason with this post operation. How can we check that? Of course, with the get operation. Let's use this get operation, so try it out. This is why we changed the default of limit to 20. We just want to print out all the users in the database. Let's execute it. So we'll look at the response body. You can see that at the bottom, we have this new user with name Jason, and its information as we've added. This is great. What if you want to customize the request body even more? What if you want the username to be of specific length? And maybe the date join should be in date format. It's time to make some improvements to our Pydantic model. Let's head back to PyCharm. This is the class user we've defined. We'll add more validations to its fields. Now, in order to do that, we need to use the field from Pydantic. So let's add it in the import statements. It is from Pydantic, so let's add field after base model. Besides field, since we're here, let's also import two more things. From typing import optional, we'll use this to make the field optional. And from datetime, import date. This will be used as a type for the field date joined. Alright, we'll go back down to the class user. For the field username, we'll set its default equals field from Pydantic. This field returns an instance of a special class from Pydantic. Within the parentheses, we can pass some arguments to the field. Let's see, the username is a string. We want it to have specific length. We can do min length equals 3 and max length equals 20. So the username must have a length between 3 and 20. Pydantic needs to validate that as well. Next, for date joined, instead of string, it should be date. We've imported date from datetime, so it's all set. Then for location, it should still be a string, but we can make it optional equals none. That means if you don't give a value for location in the request body, it is okay. And for age, it should still be integer, but we can again set its default value to field. And this time, let's put none as the first argument within field. This is another way of saying age is optional, since its default value is none. So we don't really need this optional above, but it is better since FastAPI will give us better editor support based on it. We just need to set their default value to none. Then, we can add more parameters for age. Since age is integer, numeric values, we can say GT for greater than 5 and LT for less than 130. So to summarize, age is optional, but if you do provide age, it has to be an integer greater than 5 and less than 130. For numeric data, there are also arguments of GE for greater than or equal to, and LE for less than or equal to. And that's it. With all these extra constraints, Pydantic will validate the data based on them. Other things will remain the same. We've only changed the fields of the class user, and we're still using this user as the model of request body within the post operation. Let's save it and go to the doc. We'll expand the post operation and try it out again. For the request body, we can still see the same four fields. Username and location still default as string, while date join has changed to a date. This is because we've declared it as date rather than string. Age is still 0. We'll try a couple of examples. First, let's try to change the username to, say, T. Recall that the username should have a minimum length of 3, so this shouldn't pass the validation. By the way, if you've forgotten about the criteria, you can also see them in the below section, schemas. We can expand user. You can see details of criteria for each field. Username has to be a string with max length 20 and min length 3, exactly as we've set in the code. So now we'll go back to the post operation and execute this. So, we've got an error. Within the response body, we can see some clear error messages. It's saying for username, we need to ensure this value has at least 3 characters due to the minimum length setting. Also, it's saying for the field age, we need to ensure this value is greater than 5. That is also what we've set in the model. So this is great. If we've entered data that's not the correct format, FastAPI gives clear error messages for us to fix them. So let's go back up and change the request body. We'll make the username with at least 3 characters, say Tim, and age to an integer greater than 5, say 16. Let's execute it again. So now it's the response code of 200 that we want to see. We've successfully created user Tim. Let's try another example. Let's name this user Tom. Recall that we've made location optional with default being none, and age is also optional, defaults to none. Let's remove these 2 fields. So now we're only sending data with 2 fields, username and date joined. Would this work? Yes, it worked. We've successfully added user named Tom. Now let's check the results. We'll go to the get operation again. Try it out and execute it. So at the bottom of the response body, we can see Tim and Tom are both added there. While since Tom has nothing for location and age, those 2 fields are showing now. Great! I would also like to mention that besides field, FastAPI also have similar functions for query and pass parameters. You can import from FastAPI, query, pass, and then use them in a similar way as field to declare extra validations for query and pass parameters. I won't cover those in this tutorial, but you can visit FastAPI's official documentation to see examples. In this video, you've learned a lot. You've successfully created post operations with Pydantic models. Now your clients can add validated user information to your API. In the next video, we'll look at 2 other key operations to manage the user database. Stay tuned. Did you learn something new in this video? If so, make sure to subscribe to our YouTube channel. Just click the subscribe button below this video right now. If you're interested in more data science tutorials and courses, please head over to our website justintodata.com. Thank you and see you in the next video.